video, we are going to be doing multi-step equations. So your paper, your notes paper looks different than mine. All I have are the two equations that we're going to work together. Your paper has 4 equations. 2 of them you're going to work on your own, and you're going to take 2 math workshop. You also have some steps at the top of your notes. These are for you to use to solve these equations. I will be using the same steps. I will just be saying them out loud because I do this so much that I am used to the steps in order as they go, but you have to do them in the same order every time, okay? So let's start solving these equations by drawing our lines, okay? I draw my line to kind of keep me organized. I will go ahead and draw the line over here just so I remember. I'm going to start on this equation first, and you will go along with me. So if I go too fast, just pause the video, rewatch, stop, slow down, take time to write, whatever. But I'm going to go just through these equations, and that's it. Okay. First things first is distributive property. Just like PEMDAS works, it says to do parentheses first. That's what we do also. We go find the set of parentheses. Sometimes equations might not have parentheses. We've worked with those before, but sometimes they do. So if they do, you always do the distributive property first. Distributive property is what we learned in the last video. So 2 times 3y is actually 6y because 2 times 3 is 6, and we cannot forget about that y that is connected to the 3. 2 times -9 is a -18. And remember, yes, this is a minus sign, but whenever I look at this little term right here, just as one entity, it is a -9, yes, okay? So that created a -18, but when I write that in an equation, it creates 6y minus 18. It doesn't change anything, we just say it different. All right, here's the equal sign. I did nothing with this side of the equation, so I am going to rewrite it. I am done with my parentheses now. There are no more parentheses. I can move on to combining like terms. It is important to always combine like terms on the same side of the equal sign. So first, let's see where our like terms are at all. This is alike to this because these have variables. And then this -18 and this 4 are also alike because those are both constants. We don't have like terms that are on the same side of the equal sign. As in, there's not another y that this 6x or 6y can combine with on this side. And same thing over here, even the numbers, they don't have like terms on the same side. Since you don't have that, you move on to the next step, like terms on different sides. There are like terms on different sides. These are like terms on different sides of the equal sign. Okay, what we do with that is that's when we start to use that inverse property that we use a lot, okay? Inverse property tells me that I'm going to be moving this 5y over here to go with this 6y. The reason I did not start with the 6y to move it over here, you definitely could have done that. You could have moved this 6y, subtracted 6y for both sides. That would have had 5 minus 6 would have given us a -1. It's no big deal to work with a -1, but in your brain you can kind of start working with numbers that might make things a little easier for you, okay? You won't change anything, you won't make anything wrong by doing that. It's just kind of a preference on where to start. Okay, this is going to eliminate, there's nothing here anymore. 6y minus 5y equals 1y. And remember, this is how I write 1y. If you choose to put the 1 in front, go for it. I'm also gonna rewrite this -18 right here, or -18 I mean, okay? And then there's nothing here anymore, and there is a +4. So I'm gonna rewrite +4 right here, but I technically don't have to write the plus. All it's saying now is that we have a +4 that is on this side of the equation. I don't need to write +4 because we don't usually say y minus 18 equals +4. You don't say that, so you don't write it, right? Y minus 18 equals 4. The only other thing I have to do is combine these last like terms, so I'm going to add 18 to both sides. Remember, I do not take the 4 and subtract it to go to both sides over here, because there would be nothing left on this side to deal with. So that is the reason I don't do that. 4 plus 18 gives me 22. And then this y is left all alone. And remember, it is a 1y, but we don't have to write the 1. And this is actually our answer. The reason it's our answer, we don't have to divide by anything, is because this is a 1 right here. If we divided by 1, 22 divided by 1 is just 22. So that was our answer to begin with. Okay, let's move on to this more difficult equation. This is a very long equation, takes a lot of steps, but no steps are different than what we're used to. We start with a multiplication. We start with the parentheses. Remember, parentheses are first. It is distributive property. If you have distributive property, you have to do it first. I always draw my arrows, and I want you to get in the habit of always drawing your arrows. We can do these distributive properties at the same time, just to save some steps, okay? So let's go ahead and go through them. Since there's two sets of distributive property, let's go through these at the same time, all right? So -3 times 3r. And remember, we realize we have an r, just like kind of we have y's. Remember, y's are able to be used. So our r's or l's or n's or e's or whatever. Okay, the letters. So -3 times 3r is a -9r. -3 times -1 is a +3. If you do not know those integers, multiplication facts really quickly, please use your calculator. It's going to help you to make no mistakes in working equations, because if you make a mistake way up here, your answer for sure is going to be wrong, okay, with integers like that. 8 times r is 8r. 8 times -3 is -24. Oh, scared me. Is that right? Yes, that's right. And then over here we did not do anything. There is no distributive property, so we're just gonna leave that like it is. Okay, so let's start working with like terms. So remember the like terms step. Like terms is the next step after distributive property, but there's something very important that we do first. Like terms that are on the same side of the equal sign. Put those together first, and then you start working with stuff that's on opposite sides using inverse property, okay? Like terms on the same side. So I'm gonna box all of the numbers with variables. I meant to put the plus sign with that so I know. There's like terms, there's like terms. Okay, so we have a lot of like terms here. We also could circle my constants, but I'll do that later, okay? So let's put these like terms together that are on the same, actually, I will go ahead and do that. You go ahead and do that too, please. All right, so let's go ahead and put the like terms that are on the same side of the equal sign. I notice that there are -9r's and +8r's on the same side. This turns into just a math problem, a simple math problem, -9 + 8. Use your calculator if you can't do that in your head, and even if you can, just go ahead and check yourself. -9 + 8 is -1. So we have a -1r. This is how I write -1r, okay? This 3 and this -24 are also like terms. They are also on the same side. So I'm going to put 3 minus 24. That gives us a -21. And if you can't do that in your head, please use a calculator. All right, equals. These two right here are like terms, 6r and 5r. So we have 6r minus 5r. Remember that was if I drew 6 r's on the board and I erased 5 of them, I'd be left with 1. Okay, that's how those combining like terms work. So I'm left with 1r. This is how I write 1r. And then I have this +7 here. Okay. This 7 does not have any friends to sit with or combining our terms to be alike to, so it's just going to be rewritten. So we have our more simple equation now to work with. Let's continue combining like terms. The only thing is they're not going to be on the same side of the equal sign anymore. They're on different sides of the equal sign. So now I have something that I'm going to do here and then here. So it really doesn't matter which side you move first. I see that this is a -r, and that's kind of funky to work with, so let's try to move it first. I can add r to both sides like this, because -1r plus 1r goes away. If I had if I had actually put ones here, -1 plus 1 is nothing. That's why we do that, okay? And then I move it over here to create 2r. So now I have a positive 2r, which is much easier to work with. Like I said, it wouldn't have been wrong if you would have went the other way. So it's up to you. If you can see that kind of stuff ahead of time, go for it. All right, now let's just rewrite the rest of our equation. So I have a -21 here. So now I have an even simplified version of the equation that I'm still working with. These right here are like terms. I'm going to subtract 7 from both sides. I am left with 2r on this side. Negative 21 minus 7. Please put this in your calculator if you cannot figure this out in your head. Negative 21 minus 7 is a negative 28. You might be like, huh? I thought two negatives make a positive. Only in multiplication and division. Remember that. All right, we're almost done. The r is almost all the way by itself. We're going to divide by 2 on both sides. I get r equals negative 14.